Welcome back. Today we're going to talk about a problem I ran into on Raspberry Pis. Um, Very subtle, led to a bunch of red herrings, and some work I didn't need to do, and a bunch of forum posts that were completely out to lunch and wrong. But one forum post that was correct. So, give me my notes up. We have to talk a little bit about IP numbers. And okay. So when we talk IP numbers, there is generations of change that's happened in them, the way they work and the way we handle them these days. If you go back in history, way to the beginning of when IP numbers first became available and stuff like that, there was no such thing as NATs. There was routers, but there were no NATs per se. No firewalls. And if you watch the history from the guys who actually designed the first PIC firewall device for Cisco, for example, and the private company they actually had, they talk about this. When they decided to make the IP range 32 bits of numbers, right, which you see as the 4 octets you see, like 10.0.0.0. Each those numbers has a range of 0 to 255, or in bits, 8 bits. So really, when you look at those numbers, they're 8 bits dot 8 bits dot 8 bits dot 8 bits, right? And so many of the bits are hosts, and so many of the bits are networks. So when they first did these, since there was no NAT or firewall, they just handed out the numbers willy-nilly to anyone who needed them. If you came to them and said, oh, I got this many computers in my corporation or whatever, and it totaled like 5,000 hosts equivalent, right? They could just hand you a Class B address. Now, as you can see in the table, in Class A, right, there technically is 126 networks. Each network is worth 16,779,214 working hosts. That's a lot of IPs. But the concept of non-routing IP address, I don't think was quite there yet. I don't know if it was right away proposed at the first point, or did it get amended to the specification for it. But remember, we didn't have firewalls. So when corporations need to reach other corporations out there, or education, it doesn't matter, right? Everyone was given a world addressable IP number. So you got that Class B number for your 5,000. Someone had to run around to all those systems and assign, 100 dot 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 whatever number to it, based on the block of numbers you were given. That also meant that if you were out there, this is why the internet kind of grew up with all trusting. Since there was no firewalls, you basically exposed every computer, whatever, to everyone else. This is like the heyday of hacking at the time, right? So along comes these guys, and they come up with a concept called the NAT, Native Address Translation, right? The idea being, instead of handing out huge blocks of numbers to these corporations, and then every time you figure out that someone else has got a number in your block by accident or because they didn't understand it, how do you fix it? Well, you had to go around and fix everything. So these guys who invented the PIX router and stuff said, well, why can't we just translate a block of numbers on the inside of a network to the block of numbers on the outside of the network, and vice versa, i.e. NAT, right? And at the same time, they started playing the concept of a firewall to protect things, right? Because they realized after things like the big worm, for example, the email worm that brought down everything, right, that you had to have some sort of protection. So one of the things they came up with was these non-routing IP address that you could use behind the firewall, whatever size you needed. They just wouldn't route to the internet. They would depend on that NAT device on working. So these guys here, and they also have what they call classed IP numbers. Class A, Class B, Class C. Technically, there was also a D and a E. And I think I remember in Sun documentation, very old Sun documentation, there was an F. D is multicasting, and I think E is private research now. I can't remember what F was. I don't even have that documentation anymore. But you get these numbers that you can use. Now, normally in a Class A number, for example, you are going to mask it with a set of bits that represent the network. So when you look at this Class A number up here, the one network, right, you're going to get an IP number like this, where it's 10.0.0.1 for a device, right, and a mask of 255.0. Whoops, too many zip fives. .0.0.0, like so. Now, in modern conventions, that's also known as a /8. Okay? But back then, you would set things up like this, right? Now, within a block of numbers, you're going to have a number that represents the gateway, right? A number that represents the network. So you might have 10.0.0.0 is the network representation for the whole network, right? You might have 10.255.255.255, for example, as the broadcast, like so, okay? And that all worked great and fine and dandy. But when it came down to the home networks and stuff, like when the first routers showed up for home, like we're talking like those blue Linksys and stuff like this, that started being affordable for the home user, and home users started getting real internet. I mean, more so than a PPP link on a dial-up. Actually, the first high-speed internets, cable modems and DSL and stuff like this, right? Most routers were actually given a Class C address. So, and inside the Class C non-routing addresses, you had 256 networks, and each network was worth 254 working hosts. So you would have an IP at 192.168.0.1, for example, for the router, and its mask would be 255.255.255.0, otherwise known as a /24. Okay? The /24 really means 24 bits for the network, right? 255 for the host. Now, for most people, 255 numbers on an internal network or 254 working hosts is more than enough, right? Now, you could, in classed IPs, you could divide that out. You could say this was, let's say, instead of 24, this was 25, right? And if you say something like 25, and I'll just do it in a calculator here for us, right? You'll get, instead of one network with 254 hosts, you'll get two networks on that range with 128 hosts, or 127 working hosts. 126, actually. Okay? So, yeah, you can divide smaller and smaller and smaller, all by a factor of 2. So, if you did /26, it would be 4 networks of 65 hosts. But you get the idea. But later on, what happened out there in the world is they kind of regretted giving all these IP addresses out. The IANA actually would like them back because some of them were wasted. For example, they gave, I know this by just looking at the IANA records, right, that they gave IBM, for example, a couple of Class A's. Literally, they gave IBM 2 sets of 16 million numbers. But with the rise of NAT and everything, you didn't need them anymore. They could have been returned, and then that Class A could have been divided up by subnetting to ISPs and given more numbers. Now, if you go to the IANA database and you look up your ISP. Let's say I look up Shaw. I can actually find all the blocks and numbers that they were assigned. Now you're saying, well, they're all over the place. How do you join them together? Otherwise known as supernetting. Well, one of the things that happened after a while, because of this problem where you can only divide, we got introduced to classless IPs. So in a classless or CIDR system, right, that bit number can go up and down. So if I gave a number like 192.168.0.1, but I said I wanted a mask of 255.255.254.0. So what I end up doing is doubling up. So now I have two Class Cs joined together, right, for 512 hosts. And I could keep doing that. I could go the next one down, and you can use an IP calculator to figure this out for yourself. So they usually have an option there called any. And if I go to any and I say I want 248 as in the third octet, and I calculate. Well, 248, if I say that in here, right, I ended up with 2,048 numbers. And what I really end up is 192.168.0.02, 192.168. And it's the third one to increase by 4. So we have 7.255. So we now have a working range of probably 2,046 hosts. But there is a key to this that slips my mind sometimes, and I forget about it, and I get these really nasty errors. So in a Raspberry Pi, just like in your PC here, when you assign network numbers, normally it's from DHCP from the router. But what if you set it static? Now you have to make sure you remember 4 key items when you set numbers. An IP, the net mask, the gateway, and usually the DNS. Okay? So normally you would go to something like this, your connections. And you would say in your connections, the interface over here, and you would say IPv4, for example, and you'd say, instead of automatic, right, you'd say manual. You'd put in your DNS servers, you put in your search domains, right? But this field right here is critical. It's really 3 fields that you have to fill in. The number you want to give your machine, the mask you want to give your machine, and the gateway where you're going. In my case, my gateway is .1, this machine is .50. Okay? Now, in the GUI, it's straightforward. It's no issue for this. It's straightforward. But what if you're on a Raspberry Pi? If we go down here to our console and into the Raspberry, not the gateway, but the Raspberry Pi, like so. So I'm on a Raspberry Pi with Debian Bookworm. Okay, I've installed this without a GUI. There is no GUI on this. It's actually running the 3D printer over there, and it's run Octo. Well, so technically it has a GUI on the LCD screen, but it's specifically designed to show the Octo dash interface on it. There is no desktop. In fact, in Bookworm on the Pi now, it's all Wayland for the GUI. But how do you configure the networking? Well, if you don't do anything on the Raspberry Pi, it just gets a number by DHCP and everything's kosher, right? But what if you want a fixed IP number on here? How do you do it? Well, in the old school on Debian, you would go to etc and you would go to network and you would look at interfaces. Right? And this interface file actually is a more modern one. It tells us go to interfaces.d and get our work. But you see there's nothing in there. Where did it go? Well, just like the desktop here with its GUI, this is technically all Network Manager. It is basically taken over on almost all Linux distros for setting up network. You don't configure this stuff manually anymore unless you're a diehard and you don't install Network Manager or you remove it and instead go back to setting up interfaces files, right? Where you set things up. Okay. Well, that's fine and dandy, but how do you do the command line? Well, in Network Manager, they gave us a tool called NMCLI. Now, you can see in here, Network Manager is not running, but there's no settings for it here. How did they do it? Well, in the Raspberry Pi's GUI of its desktop, there was a place where you could set your IP number and everything. But since I'm not running the desktop, Raspberry Pi gave us this tool, NMTUI. Dash edit, I think it is. Do I not have it running on this one? I might not have it running on this one. Just give me a sec here. I think I disabled it on the Octo because I didn't want it interfering with anything. I think I set it within the Octo Dash interface. Oh, how do I get there? I can't remember. Do I have that in my network thing? Did I put that in there? No, I didn't. How do I get there to show this? Well, I can't bounce that way to that. I don't have the VM up and running. Just give me a sec. I will just need to know a URL and I don't remember what it is. Not that one. Just a sec. I'll be right back. And I'll just pause this for a sec. Okay, I had a brain fart, but I remembered now. So if I go over to, this is at work, and I'm going to go over to one of our pies there. These are all unreachable by the outside world anyway, so so this is NMCLI, right? This is the tool the network manager would have you to run if you need to do anything. If you do this, you'll see there's all a bunch of parameters and stuff and weird verbiage, and it's not an easy tool to get used to, right? But Raspberry Pi provided another one. TUI edit, I believe it is. A console version. So the way you work these is just it's curses. It's you tap, 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 right? So we're going to tab to edit, press enter, right? And there's the thing to set everything up. Now, the GUI has 3 fields: address, netmask, gateway. The Pi has address, gateway, DNS, search domains. Where's the netmask? Well, apparently, and this I think is, I blame Raspberry for doing this. They should not have done this. They should actually had an extra field in here, right, for address to add a net mask. Because by default, this thing defaults to /24. Now, I don't know. I never tried this out. If I put a class A address in here, do I default to a /8? I have a feeling I don't. I actually have a feeling I end up going to /24. For some reason, that's coded in there. So I come along and I set up the networking. As you can see, it's all set up. And we'll just cancel out of here. Right? So I had set this up. Now, when you're setting up certain types of services, DHCP in particular, is kind of a catch-22, a chicken and an egg scenario. You cannot have the box boot trying to get an IP number from a DHCP server that is actually hosting itself that hasn't run yet. So it's kind of screwy. So the best thing you always do on these cases is you make them static, like I did in there. But I didn't pay attention to that net mask. And this drew me a little bit bonkers because I set it all up and I rebooted to make the static number take effect, right? And I tried to SSH in from my desktop. I couldn't connect. I couldn't ping it, couldn't do anything. But when I went over to the next Raspberry Pi, which I had not done this, but still on dynamic DHCP, and I logged in, no problem. And then from that Pi, I went back to the first Pi. It worked. Why? And the SSH error I was getting was called PEX something key exchange failure. So it's like we were trying to negotiate keys and we failed. We had either side wrong. And at first I thought I screwed up the SSH, like I messed something up, right? So I was doing, SSH dash VVV and trying to log in and trying to figure out what's going on. So, I go to SSH, like this. Whoops, too many edits. Dash V, verbose like this. And we say at 192.168.124.19, the next Pi. And I was looking at, the debug logs for SSH like this. And I thought I had something wrong here because that's what I was talking about. The Kex logarithms was failing, right? And I thought I had all the correct logarithms in there and everything was correct, right? And I was still getting the error. So I go to the forums and post after post after post says, oh, you've done your SSH wrong. You've done your SSH wrong. You're going to have to restart your SSH daemon. It's probably, and went on. I did all the steps. Nothing fixed it. I even went as far as, because I was just setting this all up, I went as far as I hadn't actually started the DHCP part yet or the DNS or anything. I was just getting the 4 Pis basically set up. I went back and I reset that micro SD card. I reinstalled from scratch, voila, I could log back in again. As soon as I set it to static, I lost the ability to log in. Couldn't figure it out. Didn't know what was going on. Right? So when I went looking at the NM TUI edit tool that I used, and I went in here, and one forum post after must have been about 30 postings about this in about 5 different sites. One guy says, "Is your net mask right?" And like a light bulb that went on. And when I went in here, this /21 in here wasn't there. It just ended in a blank. In fact, this thing didn't even put /24 on the end. It just assumed the /24. And the way I noticed this is that I did an ifconfig, and I looked up here, and that was 255. Now remember, when we're supernetting stuff together, right? And we are joining it with a mask of like that, and we have 2004. We actually have 8 Class Cs side by side, toing, 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 toing. As far as it was concerned, I could access the 124 part of the subnet. So I had 120 through 127 on that third octet. That was my block of numbers. But I could access 124, but only from another 124. And it was a case of Homer, duh. Why did you do that? Right? And I went back, of course. If I can get back there. And I in the editor, and I look for that field, the field to set the NAS mask. I couldn't find it. And I'm going, what is going on? What is going on? That doesn't make sense, right? Because the GUI for Network Manager has it. And then I realized, oh crap, they want me to write CIDR notation. Why didn't they just put that in the GUI that the IP address needs to be CIDR notation? And a good GUI, right, when you do them, might actually have in grayed out fonting an example to show you what they're expecting that field to actually contain, so that you know to put the right stuff in there. Well, they didn't, and they didn't have a separate field in that map. So, okay, I go look it up. Yes, it's /21 for 248 in there. I put it in, I saved it all, restarted. Everything was fixed. So the moral of this story is, right, once you start playing with CDR, you got to really pay attention to masks on these things. And you have to pay attention to the damn Network Manager tool, because it's not consistent between the text version and the graphics version. Now, I didn't do this as NMCLI. I could have probably, and it might have warned me that I haven't set a net mask, and it might have shown an example of it. But the text version, that's sloppy, right? I believe if I had put the number in there and not specified the mask, it should have popped up a little warning and saying you need to specify, not assume /24. Right? Because in modern routers and everything like that, we are deeply into the CIDR version of it. There is technically no Class A, B, or C anymore technically out there. Right? We either subnet it or supernet it together. So we either take a number, like our number for our internet, from the ISP, they subnet it so we get a block of 8 numbers. And in that 8 numbers, one of the numbers is the gateway for the ISP wants us to use. One represents the network, and one's the broadcast. So it leaves like 5 working numbers in there that you could use. But this is the other way around. So once I realized what was going on, and the error from SSH was so lame, where it says, Kex logarithm failure. It's like, huh? And it also explains, why I could connect the course from another Pi, because it was on the same 124 block. So this was like a bunch of red herrings, bad forum posts from not understanding this. And I had to go back and just do a little bit of reading in that to make sure and then I realized, of course, that makes sense. Once I found that little section in the book that told me that you can, if you have the wrong net mask on a client, you can only speak within that subnet. You cannot speak outside of it. Right? So I hope this really helps some people on deciphering all this and making sense, especially if you choose to supernet. Oh, and by the way, if you're using the OpenWRT stuff, Tomato or anything like that on Netgears or SUSEs or whatever, any of the routers that have that, I actually found a problem in one of them. I couldn't supernet, and I couldn't put anything but a Class C number in. The router complained and said, no, that's not valid. So these guys, when they do this, they have to test for this, make sure the code actually works. But I still blame the RPI console app for this. It should have been more clear what was actually needed in the fields. Now, some people go, oh, that's obvious. Well, it wasn't obvious, right? They should have said, a little thing on there says, x.x.x slash x, x. So then that would have right away told me that I had to use CIDR notation. Or they could have just said at the top, need to use CIDR notation for setting IP address, right? Then it would all be fine. But this was this little problem I have with the Pies. So if you're dealing with the new Pies and the new Bookworm OS and you're dealing with the Network Manager, be careful of this, because this will drive you to drinking. And I don't need to be back into here. Exit. And not into here, and not into here. And doink. Yeah, I love this redirection. Log into one machine to log into another machine to log into a Pi. Yes. So I hope that helps people. And I'll end this. So this is I have another interesting problem that's even a little more detailed. It's one dealing with OpenVPN and edge routers from Ubiquiti. And I think I'll construct a video on that. So bye for the moment.